Exercise 7C, question 28. The question gives you the coordinates of the center of circle C is -4 and 2, and the radius of C is square root 10. Part A, it asks you the equation of C in standard form. So, very easy, because you have the center and also the radius, then you can directly plug into the equation. So the equation of C, it should be x plus 4 all square plus y minus 2 all square equals to the root 10 square. Because you need to answer in standard form, so what you need to do is to change the square root 10 square to 10 and copy the remaining part. You get part A. Part B, it asks you to find out the equation of L1. The equation of L1. So you know that the straight line L1 is y equal to mx, m1x, and m1 will be larger than 0. And this straight line is touching C. So we can also tell that the equation of L1 is actually the tangent of C. It's the tangent of C. So later on, you need to think about the delta equals to 0 because it's a tangent touches C at one point only. So part B. Part B. You have two equations. Firstly, it will be your equation of C, so circle equation. The second one will be the straight line L1. So y equals to m1x. What you need to do is that you substitute, okay, change the y into m1x, okay. So you will get this one, m1x minus 2 here, and then you need to expand it. Remember here is m1 square x square minus 4 m1x and plus 4. And also I changed the 10 to -10. Okay, and then you group them up. So you see that x squared here and m1 square x square. So you can get 1 plus m1 square bracket x square. Next one, for the x, so you get positive x and negative 4m1x. So you get x minus 4m1 bracket x. Finally, others, the remaining one will be constant. So here, it will become the plus 10 equals to 0. So now here you get the form, okay, of the similar to the quadratic equation. Therefore, next line, delta equals to 0 because it's a tangent to the circle C. For delta, b square minus 4ac equals to 0. And then you expand it. And then also you group them up. So you get 24m1 square plus 64m1 and then minus 24 equals to 0. So later on when you use formula 01, you can get m1 equal to 1 over 3 or -3. Before we jump to the final conclusion, let's go back to the condition. So m1 today is larger than 0. Therefore, we have to reject the -3. And don't stop here. We have to answer the question. Therefore, our equation of L1 will be y equals to 1 over 3x. So, or you can make it as the general form. So, x minus 3y equals to 0. Okay. So, let's see. There is another equation, L2. Y equals to m2x and intersect at C, okay, intersect the C at 2 points. One we call A and another one we call B. We know that x1 and x2 are smaller than 0. O is the origin. And show that the product of x1 and x2 is these expressions. Okay, so before we jump to the calculation part, let's draw the graph first. Let's draw out the graph. So actually we know that our radius is root 10 and also the center, okay, is -4 and 2. So what can we draw? Firstly, we draw out the xy axis first. Mark the center, so you get the -4 and 2 will be here, okay, and then in this quadrant, and then you can sketch the circle first, so it will be something like this. Why it touch the x-axis? I mean not touch, but intersect at 2 points because here, because the radius is square root 10, and the height, okay, of the maybe the y coordinate of the center is 2 only. So square root 10 will be larger than 2. So it touch 2 times, or maybe it intersect 2 times. But then it cannot intersect at the y-axis because here should be 4. But then the radius is only square root 10. Okay, and then for L1, we know that it's intersect at C. And then it's touch at C. So we know that L1, because it's a special straight line, so it has the y-intercept or maybe also x-intercept is 0. And it has a positive slope, so we can draw it like this. Okay, so it touched 1 time, and this one we call L1. And now we get the L2. L2, we don't know the slope, but we can pretend that, okay, maybe it is a -1, okay, or maybe positive, as you like. Just what you need to do is that it intersect at 2 points. So, for example, I draw it like this. But remember, after you draw this one, you must have the L2 also touching the origin because it's also a special straight line, y equal to mx. So I pretend that this one is L2 and it touches the intersect at A and B. So show that the x1 and x2 equals to 10 over 1 plus m2 square. Okay, now we know that actually the root, okay, it is the product of root. So we go back to the equation. So for C1, firstly, we have the x plus 4 all square plus the y minus 2 all square equals to 10. And also the y equals to, today is m2x. We can do the substitution again, so we get the x plus 4 all square plus the m2x minus 2 all square equals to 10. Expand it again, so you get x square plus 8x, okay, and then plus 16, and then plus m2 square x square minus 4 m2x plus 4 minus 10 equals to 0. And then for the simplify or maybe factorize out, so you get this one. If it's, the steps are similar to the one in part B. And then our conclusion, we need to have x1 times x2, right? So we call this one is the product of root. S4 concept here. So in S4, we know that the product of root is actually equals to the C over A, right? So if we think that x1 is our alpha, x2 is our beta, this is our product root. So today what is our C? C is 10. What is A here? A is 1 plus m2 square. Therefore, x1, x2 equals to 10 over 1 plus m2 square. That's it. So what you need to show in the step is that you need this line and tell me that this is about the product root. Part C2. So C2 express the length in terms of m2 and x1. And also express the length of OB also in terms of m2 and x2. So later on, after you calculate the you get the expressions of OA and OB, then you need to find out the multiplication of them. So let us going back, okay, to the graph. So we know that A is x1, y1 here, and B is x2, y2. O is origin 0, 0. So the length can be clearly shown. Okay. Let's go back to the below part. So C2, we know that OA is actually equals to the distance formula. By using the distance formula, we get x1 minus 0 all square plus y1 minus 0 all square. But actually, we know that y1, okay, equals to m2 x1, right? Because x1 and y1 is on L2. So we can substitute back into the equation. Therefore, it change. The equation becomes x1 minus 0 all square plus the m2 x1 minus 0 all square. Simplify it, you get by kicking out the 0. So x1 square plus m2 square x1 square. Factorize out the x square, x1 square. So you get this one. 1 plus m2 square bracket x1 square. By using the concept in S2, you get square root AB is actually equals to square root A times the square root B. This is the concept. Therefore, we can separate in this one. So we get x1 and then square root 1 plus m2 square. However, it's not the end. Why? Because we know that x1 is smaller than 0. So we have to add an extra minus sign in front of the OA here. Why? Because OA is a distance, so it should be having a positive value. But if we don't add an extra negative here, inside the short form, okay, here must be positive. This one must be positive. And x1 is negative, right? So if we didn't add an extra negative, the whole thing will become negative. So we need this extra negative to make the whole expressions become positive again. Okay. to satisfy the condition of OA distance. So OB will be the same. OB will be the same. So for OB, you get square root x2 minus 0 all square plus the y2 minus 0 all square. And actually we know that x2, y2 is on the L2 also. Therefore, we have y2 equals to m2x2. Substitute again. So the steps are the same. So I skip a bit. Again, you have to take out, okay, you have to factorize out the x2. So here. Again, after you factorize out the x2 by using the concept square root a times b equals to square root a times square root b, you need to add an extra minus sign again because OB is positive value. Next one, for finding OA times OB. So copy the expressions and then you get the positive, okay, value. And then x1, x2. And what is x1, x2? By here, you are using the part C1. So you get 1 plus m2 square and then 10 over 1 plus m2 square. Cancel them out. You get OA times OB is actually equals to 10. Final part. So you have the length OB is 5. So we can mark it down. So maybe you need to zoom in a bit. So if I know OB here is 5. And then the question asks you, find the perpendicular distance between L2 and the center C. So you know that the center C, okay, and you get the L2 here. So the cross in the middle is C. And I want to calculate the center to the perpendicular distance, okay, from center to L2. So it's the green line here. So perpendicular, you think about 90 degrees. And also, what is the concept behind? Because OA, this line, the pink line, this one is the chord. AB is the chord of circle C. Then therefore, what we need to think about is that chord perpendicular bisector, okay, will passing through the center. So you mark down this one. And also you have another line, the center to B. This one is actually the radius. So you know that this one is the square root 10, which is the radius. Your job is to find out the green line. Okay, is to find out the green line. And before we calculate this, you have to know about find out the AB first. The AB first. How to find out AB? Because you know OA, and then okay, after you know OA, you use OA minus the OB, then you got the AB. After finding out the AB, you need to find out half of the AB because it's the perpendicular bisector line. And then lastly, you can see a right angle triangle here. By using Pythagoras theorem, you can calculate the perpendicular distance here. Seems a lot of job. No worry, let's do it together. So find out, okay, because we know that C3 OA times OB equals to 10. We know that OB is 5, so multiplied by 5 equals to 10. OA is actually 2. No worry, you see that, oh, why OA is shorter than OB? No worry, just remark the graph wrongly. Later on, you can change it. Actually, you know that our graph will be like this. So, actually, your B position will be A, and A position will be B, as O boy is longer than OA. So no worry to change your graph. Okay, your sketch, okay, is just helping you to solve your problem. Okay, you may need to always change your graph every time by adding some of the extra information. So, and then after we know OA, then we want to calculate the AB. AB is actually equals to O boy minus OA. Then we get 5 minus 2 equals to 3. So by calculating the distance, so we can say that the required distance is the square root, okay? So the radius square minus the 3 over 2 all square. By using a calculator, you get square root 31 over 2. So the key point is that you need to know the perpendicular bisector of the chord will pass through the center. Second step, you must know that the Pythagoras theorem. So this is all the solution about exercise 7C question 28.